Up next, we have Oded Hareven from Akeyless. Oded, a veteran of the IDF Cybersecurity Elite Unit, specializes in identity and access management technologies and has held various senior product and project management positions in both enterprise organizations and startups. Among his previous roles were Director of Product Management at Moveit, acquired by Intel, and a Senior Project Manager at CA Technologies. Oded holds a BA in Management and Economics from the Open University of Israel. Welcome, Oded Hareven.
Well, hi everyone. My name is Oded Hareven. I'm the CEO and the co-founder of Akeyless. I'm going to speak to you today about next-gen root of trust, and as you can see, the infinite scaled encryption in a hybrid and a multi-cloud world. As of my background, I'm a retired captain of the Israel Defense Forces. I've done a lot with cybersecurity during the last 20 years, a lot of with identity and access management, privileged access management, all around information security infrastructure. And of course, different types of development product and ops operational positions. So let's start from the beginning, and just in a very short time, who is Akeyless? Well, Akeyless is the one behind the Akeyless Vault platform. We're offering different types of solutions on top of one platform, which is SaaS-based and globally available. Secrets management, secure remote access, and data protection. I'll speak about some of them later on, but beforehand, just to have some clue about who we are, we're serving different types of customers in different sectors. We're FIPS validated, SOC 2 Type 2, ISO, Gartner, basically talking about us for some time now, with the hype cycle later on with data security and identity and access management. I'm recommending obviously to go with that. So enough about that, and let's talk about the actually things that we're here to talk about, which is the modern computing that have dramatically evolved. And this basically means that we are seeing private and cloud that emerges, and we see that in every organization. That's not a new thing. That's true. But what we do see is that there are all kinds of technologies that have come up, and they demand all kinds of things that happen, right? Containerization basically means that the monoliths have broken. There are a lot of more containers that need to speak with each other, and there is a lot of burst and ephemeral resources that have the need of cryptographic operations. The automatic scaling basically means that obviously everything can scale without the need of any manual work. Speaking of manual, and speaking of which, automation is widely used, and the operations have become much more global than what they used to, with multiple regions that are being adopted and so on and so forth. And of course, the environments have been not just hybrid, but also multi. So this is with regards to the adoption of things that happened in the last few years. Now, what happens is also that we're moving towards a software-defined future, or present, if you wish, with all of different aspects with that software that slowly but surely kind of changes the way that we're dealing with infrastructure, dealing with operations, dealing with DevOps, right? This is the new world in which we are at. But if we had back then the world of on-prem fixed resources, a lot of manual work, we're moving into obviously even private or public cloud, which is very much automated, and lots of it is ephemeral resources based. All you see here is just an example of software-defined networks and perimeters, the compliances code in which we can basically code things instead of have some very slow and not very efficient configurations. And that's basically, this is what it means. This is the software-defined world and all of those trends within it. So talking about all of this, about this trend of things that have happened in the last few years, and including also the software-defined revolution, if you might say, it's a good time to speak about hardware, right? Is hardware root of trust really the best solution for us today? Where obviously, in the last few years, we've seen all kind of, different attacks. Some of them have happened 10 years ago. Some of them are still happening. on CPUs, SGX, all kind of hardware-based technologies. And it seems like hardware, it is good, but it might not be invisible as we thought it was be. Now, in terms of scalability, hardware is obviously a hardware box. If you need to scale that, it's not well designed to do that, right? You need to have a Black Friday e-commerce company, right? A Black Friday that comes along, and then you need to provide a large transactions basically, and you have problems when you're working with your hardware because you need to buy a lot of those HSMs, right? Instead of just working on with some scalable and agile solution that could have provided automatically and quite efficiently in terms of software-based and microservices way and so on and so forth. In terms of accessibility, the usual HSMs, if they live in the cloud, how does an on-prem service would actually call that cloud HSM? How does this work if they don't share the same identity and access management system? How this works, reverse. How does a workload that works on the cloud actually approaches an on-prem HSM? How do they authenticate? They need to have some kind of an API key there. And then if you're using API key, what's good with the fact that you provided your encryption keys within an HSM, where eventually you have an API key, you have some secret that is like the way to get to your kingdom. So definitely HSMs need to provide some kind of this, and as long as they don't provide any secret zero solution for that, they are vulnerable. In terms of identity and access management, this is quite similar to accessibility. It's not just a network problem, rather than also the identity. How can you identify yourself and towards the HSM? And of course, when we speak about HSMs, it's about supporting different types of platforms, SDKs, APIs, and so on. And last, but obviously one of the most important ones, when you have cloud HSM, someone else is running your HSM, basically. Someone else is running your hardware, and they're under the Cloud Act, maybe. And this basically means that you don't have exclusive ownership of your encryption keys. Someone can get to that. So if that said, there are some requirements when we speak about root of trust, and what would be the requirements for those, that next gen, how does this need to look like? Obviously, the next gen root of trust need to support auto scalability, a lot of efficiency in terms of resources, not to have 50 HSMs just back there. You need to have them, to grow automatically and to release the resources automatically whenever you need it. In terms of accessing your root of trust, you need to access it whenever, anytime, anywhere in the world, and also to use different types of identity and access management systems to support cloud service providers, IAM, and so on and so forth, to make sure that you don't have any secret zero that deals with that HSM, right? You need to have some next gen root of trust that knows how to speak the language of the existing zero trust authentication that we're having today in these days. Number three, as with requirements to the next gen root of trust, is the ability to provide exclusive ownership of your keys. If you're having an encryption keys managed within the cloud, you need to know for a fact that you are the exclusive owner of those encryption keys, and no one, to include also the cloud service providers, any federal government, anyone could somehow get access to your encryption keys. So you need to know for a fact that this is the case. And the next gen root of trust would also provide some better interfaces for automation and developer friendly, right? API driven, lots of SDKs in multiple languages and so on. And finally, NIST FIPS 104-2 certification. This is a must-have for any kind of root of trust solution. So this is the requirements. And right now I want to speak to you about distributed fragments cryptography. As you can notice, distributed fragments cryptography is a patented technology by Akeyless. In a nutshell, it's an innovative key management system technology, or key management technology that is able to run cryptographic operations using fragments of encryption keys without ever combining them. I know it sounds like magic, but as a matter of fact, it is. So the thing is that whenever you're asking that you need the technology to create a key, basically what is being created is fragments of those encryption keys, right? Never encryption key as whole. Those fragments are being created on different regions, on different cloud providers. Whenever the actual encryption takes place, it takes place on the customer end, right? So the technology is SaaS-based by nature. It is planned to the distributed world of where we're at. So basically, the requestor of the encryption doesn't need to download, neither combine those fragments, right? So what happens is just some mathematical materials that is being sent between all of those parties, but eventually, in parallel, all actions are being made to reduce the traffic, to reduce any potential problem of any latency or things as such, or everything happens in parallel. And the encryption takes place on the customer environment, on the requester environment, while there's a service that can actually store, create, and also refresh those different fragments of the key. The reason that the fragments are being refreshed is in order to make sure that the key itself is highly secured, since for a malicious attacker to gain access to those fragments of different regions, they need to attack all of those locations at the same time in a simultaneous attack vector, which are known to be very complicated, which is very good to protect those keys. Now, there's another element within the distributed fragments cryptography, which is the way to actually provide the requester, the customer, to actually provide them the ability to create their own customer fragment, right? So in this illustration, there's no just 3 fragments rather than 4 fragments. And this ensures that that the provider that holds those encryption keys, in that case, Akeyless or whatever who holds that technology, is able to basically run the system itself, run the service, while the provider doesn't have access to the entire encryption keys fragments. And this means that the provider has zero knowledge on the customer keys because they don't have all the fragments of the key. Okay, so the encryption takes place on the customer end. There's customer fragments only on the customer environment in which the provider cannot see. And that model basically supports the zero knowledge manner, which obviously would protect also from federal governments and protect from any third party that would like to somehow get your encryption keys on the cloud. So this is basically an enabler to protect data on the cloud in a distributed, non-trusted environment. Now, when you take this technology and you bring it to a global service scale, you can actually now speak about, how can we take those fragments and we can actually, have high availability by just replicating them between regions and cloud providers. And this is basically what we've done at Akeyless. We've taken that technology and we've got into a position where even a single region is down, still we're providing that service. So it's a highly available, highly scalable, and this is again as a result of just managing encryption keys fragments rather than encryption keys as whole, right? Again, something that a property of the technology itself that allows us to leverage and to elevate the level of availability as a result of managing keys fragments and not encryption keys as whole, right? So this is like how we see the future and how this needs to look like and to enable a lot of those. So speaking of enablement, those are the benefits of distributed fragments cryptography. We're talking about infinite scaling, obviously, and global coverage, as I've shown you. The identity can actually be managed, zero trust identity, to identify to the service itself. It's cloud native. So all the cloud service providers, IAM technologies, also some Akeyless universal machine identity is being supported. It's all SaaS based, so no deployment whatsoever. It's not hardware. Although that it's not hardware, we're still providing ultimate protection with FIPS 140-2 certified, and that's the technology itself. Having this customer key fragment to support zero knowledge, it means that there is an inclusive key ownership, as I've mentioned, as a requirement of that. And of course, it's a Cloud Act protection for that sense, and developer-friendly connections and integrations using APIs and SDK of any language as is. So on top of that technology, of that next-gen root of trust, we have built a platform that provides different types of services, different types of products. The first one is secrets management, in which it has the ability to inject secrets to any type of DevOps platform application that is being built. Secrets are any type of authentication, authorization objects like passwords, password certificates, credentials, SQL credentials, SSH keys, whatever is needed. And this is usually this particular use case where a certain application requires a certain password or credentials. Then we're able to provide that using any one of the plugins and SDKs that we provide. And this means that the secrets themselves, the password, the credentials are always encrypted using the DFC. Certificates are being signed using DFC, the distributed fragment cryptography technology. And this is how the actual application can basically not have the secrets stored on local disk, and to have a higher security by having those secrets to be dynamically created and short-lived certificates to be used. And all of that is being enabled by the Akeyless Vault platform. And then the application can use it in order to authenticate to any database or whatever it needs to authenticate, source repository, and so on and so forth. The application can also be obviously Jenkins, Ansible, Chef, whatever you need, not just the in-house developed systems. So this is the secrets management. And then secure remote access is basically where everything stands within access, and behind the access is basically credentials to validate the identity, right? So anytime you need to access as a human being and not as a workload, right? Secrets management is all about workloads to workload, and secure remote access is more about humans to machine and the way that they interact. So behind it, always cryptography, right? The same, we always go to that root of trust that need to be there, because when you need to sign for certificates in order to authenticate to Linux server with the necessary certificate, or to authenticate your Kubernetes cluster with the TLS certificate, you need the certificate authority to do so, and you need a root of trust to have this private key to be stored and protected. And this is what we provide on top of one unified platform. So this is the secure remote access. It's a VPN-less solution that provides also temporary credentials that are being created in order to seamlessly provide enable the whole process of access from home, access from your remote location to any internal environment. Internal environment can be public ones, private ones, whatever. We provide Bastion there, and we totally isolate the session, including also session reporting. So this is where we've leveraged our capability to create just-in-time secrets with a root of trust capability in order to sign certificates, encryption keys, everything together as one. The third product that we're providing on top of one platform is the data protection. And all of that all together comes into, as you can see in front of you, lots of cryptography related services with encryption as a service, KMS, obviously, with full key lifecycle management and digital signature, all based on the distributed fragment cryptography that I've mentioned. As the next gen root of trust, we built that on top of it. So we also have the ability to manage a multi-cloud key management system. Means that we can provision those encryption keys management to any bring your own key. KMS started with the AWS, of course, as the first one, and soon also Azure and GCP. KMIP, in order to interact obviously with your storage devices, and you need to have some centralized key management system within your on-prem or hybrid environment, whatever. KMIP is enabled by Akeyless Vault platform, and soon to provide also tokenization and TDE as we speak. So that was around the next gen root of trust and how we provide that, and how is it that we came into it, and why we think it's important. And this is the Akeyless Vault platform once again, and some things around who we are and what's the benefits that we provide as is. In terms of further reading, just for you to go deeper into understanding the root of trust itself, why are we speaking about next gen root of trust? There's two parts here. One of it was published on HelpNet Security on last June. There's also the continuous of it is part 2 within our blog, within our website. And I encourage you obviously to go there. There's some links here for you to use. And if there are any questions, you're more than invited to come over and to contact us directly. Thank you very much for this opportunity. It was great to speak with you all. And I'll be happy to have your questions and answer them later on. Thank you.